Uh, hmm. Hello, hello, hello. How is everybody doing? Uh, all right, we'll be starting here in just a minute. Hope y'all are doing well. Sorry about the delay. Started here in just 1 minute. All right, are we up and running on the main projector yet? Can you guys hear me? Let me know in the chat. Are we up and running on the main projector yet? Hello, hello. Let me know in the chat of YouTube or in Slack, however you prefer. Let me know what's going on. Oh, hello. If you're all right, projector setup. Thank you very much for doing that. Appreciate it very much. All right. Today we are going to talk about end user programming and excuse me. Let's go ahead and get started. We switch to the right slides. All right. End user programming. This is a very special type of user set. Hold on a sec. All right. Anyway, it's a very special type of user experience called end user programming, and it's when you actually have to try and get the user, end user, we call them, to do a bit of programming like activity. So, and this happens, not all the time, but it happens more than you think, and it's definitely something you're going to run across in your professional life, and that is why we're talking about it. Okay, so this is something that you're going to run across, and if you do it wrong, it's going to cost you a lot of time and effort. If you do it right, it's going to be very simple, okay? So let's just look at it real quick. What is end user programming, and which ones have you ever personally tried? So these are different examples of end user programming. Which ones have you tried? I'm going to put a link here in the chat so you can do that. All right, so it looks like several of you have done Excel. Of course, pretty much everybody's done Excel. Some people have done MIT Scratch, which is I would think the most popular one. Besides Excel, Lego Mindstorms is also something that people are familiar with. That's one of the things I learned on. If you've done Lego Mindstorms and you've done LabVIEW, which is very similar, actually, Lego Mindstorms is built on top of LabVIEW. And If This Then That is a home automation way, a way to automate your home certain ways. So it looks like y'all have a fair amount of experience with this as kind of consumers of these products. But let's talk about these products or this like type of user experience a little more closely. So, for instance, here's an example of Mindstorms, and this is what we would call a data flow example of end user programming, where you drag and drop blocks and the thread of execution kind of goes from left to right. Well, it really flows from start to finish along these either connected blocks, or you can see it's connected by a line here, and this is some kind of a loop here. This Lego Mindstorms approach, for those of you that are familiar with it, is actually built on top of something that is used widely in industry, which is called LabVIEW, and it's used to automate like chemistry and testing and all kinds of interesting stuff in manufacturing. So you may have thought that you were just playing with Legos, but you were actually kind of learning some professional skills. This is an old version of what LabVIEW looked like. We'll look at some other versions of what LabVIEW looks like right now. It's much more professional, obviously. But it is basically like this kind of flow diagram. Now, another type of flow diagram that exists is Node-RED, and this is, again, not as popular, not anywhere near as popular as LabVIEW, but it is a type of programming, end-user programming. And here, data flows in on the left, and it goes through a sets of like kind of filters and things like that, and then it flows to the right, and then there's some kind of output like to a file or to your screen or whatever. So this is, again, some kind of data flow language. Other examples include If This Then That, which is, how many people in the chat, how many people have ever heard of If This Then That? You can either hit heart in Minty or just let me know in the chat. Has anybody ever heard of If This Then That or used If This Then That? That's still a thing that people use, or a few people have. It's a very simple way to automate some basic tasks. It's built upon the principle of if this happens, then do that. And it's actually a way of programming kind of by configuration. Yeah. I agree. It was very nice until I got monetized. So anyway, it's a configuration like thing. It is end user programming, but it's end user programming via configuration. We're going to look at the differences between some of these things later on. Another way of doing some end user programming is actually through what are called behavior trees. So this is a tree where you start at the top, and in order to execute this program, you actually go to the leftmost leaf first, execute that. Then you go to the next leftmost leaf, execute that. Then you go to the next leftmost leaf, execute that, and so on. until you go all the way through. And so this is another way of programming. In my opinion, it's not so intuitive to express programs this way, but it has been used by a major supplier of robots as recently as about 5 years ago. So some people have tried to use this. And some people do use this, I think, actually in video game behavior, like the programming of bots and things like that in video games. All right, another way to do end user programming, which is by far the most popular in the world, is Excel. Believe it or not, this is the most popular form of end user programming, Excel. The inputs that you put into these different boxes, of course, can be little programs, and then putting them all together and referring to each other can make some very, very complicated programs. In fact, my accountant, when I worked at ABB, he had a super complicated Excel sheet that I guarantee it would take you a whole semester to understand what he was doing with, so that you can get some really complicated programs written in Excel. Another one that I want to talk about is just general home automation. And here you can see a good example of configuration style programming, where it's really just like kind of web forms that are helping you to program. So it's almost not programming because you're just configuring things, but it is in fact setting up a program that will run. Now, one of the things that I want to show you real quick, actually, let me set this up. This is just going to take me a second to set up correctly. But I'm going to show you a quick video on ladder logic, which is a what do you call it? A language that is used in industry to program things like PLCs, conveyor belts, and small machines. And this is a very popular end user programming language that's used by hundreds of thousands of people that you've probably never heard of. So anyway, let me set this up. It's just going to take me a second. Hold on 1 second.
PLCs and ladder logic, introduction and examples.
All right, here we go. Are you ready? This is just a quick introduction to ladder logic so you can understand this PLC language. Check it out.
PLCs and ladder logic, introduction and examples. Programmable logic controllers, or PLCs, are computers with enhanced hardware that can withstand industrial environments. They are used to control manufacturing processes such as small-scale assembly lines. Designed to be operated by engineers with limited knowledge of programming languages, PLCs can be used to automate many common industrial scenarios. To program a PLC, most users use ladder logic, a graphical language inspired by circuit diagrams from relay logic. In ladder logic, every program is represented by a set of diagrams, and every diagram is made up of symbols representing input and output elements, such as buttons and conveyor belts, and lines, which are responsible for connecting those symbols into the diagrams. In this diagram, symbols are shown in red, and lines are shown in blue. To build a diagram in ladder logic, we have to follow a sequence of steps. A diagram always starts with two vertical lines, called power rails, between which circuits are connected. One or more lines, vertical and horizontal, are added, connecting the two power rails. Each connection between the power rails is called a rung. Input and output symbols are placed on the rungs and identified by descriptive labels. By definition, every rung starts with one or more input symbols and ends with one output symbol. If you are still confused about what inputs and outputs can be, here are some examples. As inputs, we usually have buttons, switches, and sensors. As outputs, we usually have motors, buzzers, valves, lights, and many others. To understand what a diagram is expressing, we follow some rules. A diagram in ladder logic is always read from left to right and from top to bottom. Each rung on the diagram defines an operation in the control process of an industry, such as turning on a light or the activation of a hoist. When a diagram is executed, the power flow cycles through the rungs from left to right and from top to bottom. Notice that there are different ways of representing the inputs and outputs in a diagram. For this survey, we will focus on 3 different symbol representations: the normally closed and normally open contacts to represent inputs, and the coil to represent outputs. Let's start with an example in ladder logic. In this example, we will use a button to turn on a light. The possible values for the light and for the button can be represented by the table below. If we use an open contact to represent our button as follows: when the button is activated, or true, the light will be on, or true. On the other hand, when the button is not activated, false, the light will go off, false. If we change the input symbol from the open contact to the closed contact, the logic of our diagram will also change. In such a case, when the button is activated, true, the light will be off, false, and when the button is deactivated, false, the light will be on, inverting the logic of our output. This diagram not only represents a different way to activate a button, but also represents the NOT operation in Boolean logic. In a more complex situation, we may have to use 2 buttons to activate the light. If we use 2 open contacts in a sequence to represent our buttons, the following control process will be executed. When both buttons are activated, true and true, the light will be on. Otherwise, the light will always be off. This phenomenon happens because every time a button is not pressed, false, the power flow will be interrupted at some point of the circuit, preventing the activation of the light. The diagram also represents a Boolean logic operator called AND. Our inputs may not be in sequence all the time. Parallel inputs are also accepted, and we can see in the following example. In such a case, when both buttons are activated, true and true, the light will also be on. The difference is that the interruption of one button will not prevent the light from turning on. Notice that the only case where the light will be off is the case where both buttons are not activated. This diagram also represents a Boolean logic operator called OR. This has been your short primer on PLCs and ladder logic.
All right, so I hope you feel like you now know ladder logic. There's not going to be any quiz on ladder logic itself. What I wanted to show you is that this is a language that hundreds of thousands of engineers have had to use, maybe even millions actually over the years, but currently hundreds of thousands of engineers worldwide have to use it. And the choices that people made in designing how these end users were going to have to program really affects people's lives. In the case of ladder logic, it's probably not for the best. Although it was easier at the time than what you used to have to do, at this point in time, there's probably a better way to do it than ladder logic. But I digress. There are other things that I want to bring your attention to. This is called Vault, and this is used to program AI in video games or just items, objects in video games. It's kind of a data flow like language. And one thing that I wanted to just understand about y'all's background before I move on is, have y'all ever used Scratch? Because I've gotten conflicting reports from your generation. It seems like maybe y'all missed this, or this wasn't as popular as I thought. Right. So this is interesting because this is, in my opinion, Scratch is like one of the it is the most popular learning language in the world right now, especially for young kids. And so it's surprising that so many from your generation, where it did exist, have not actually touched it. So I do want to take a quick minute I'm going to demo it real quick, and then we're just going to make a app real quick, just a real quick app. So let's just take a quick look at Scratch. Okay, so for those of you that don't know how to use Scratch, here is the basic programming area. Here is the basic code that you can use. And what you want to do, let's say, usually you want to start with a when the flag is clicked, start my program. And you can do things like move the cat 10 steps forward. Then you could have him turn. So when I press that flag, he will both move and turn. Pressed it. I'll press it again. All right, I think you get it. And of course, you could have him do that 2 times in a row, maybe. But he does it really fast. So it just looks like he's turning further. And of course, you could do things like repeat that idea like 10 times if you wanted to. Then he'll just turn around like that. Anyway, you can do all kinds of stuff like that. What I want you to do, because so many of you have not done this before, we're not going to take 10 minutes because we're going to try and cut class a little short today because the provost is talking to my department and not my department, not college, and I need to go to that. So we're going to take just about 5 minutes to create a simple Scratch project. So just go to MIT Scratch, and I want you to learn how to use the basics of Scratch. Shouldn't take you more than a few minutes, but I think it is important that you have the basic experience. So just take 5 minutes. Do this, and we'll be back in just 5 minutes. All right, go, 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 go. Scratch, 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 scratch. You've had a minute to do it. You can put your URL in this Minty, or you can just come on back. If you have any questions, put them in the chat. somebody's asking, how do I share the project? So you have to have you have to join Scratch or sign in, and then I can't remember you have to sign in to do that if you want to do that. So just so you know, you'll have to sign in if you want to share your project. But no big deal. I wouldn't worry about that. I really just wanted to make sure that you had just about 5 minutes. That was probably about 5 minutes to play around with that. Um, it's important that you have done that, but not that you're an expert. Okay. So, other things that you can play around with, and again, you can always go to these links after class. Open Roberta is one of my favorites. You can, I'm loading this real quick, but you can do things like use the Open Roberta sim and like move, you can move your motor, and then you can, when you press play, you can like actually simulate a robot running around and things like that. So anyway, it's a cool platform. There you go. You can see, here's my program, here's the simulated robot. I can hit play and he'll drive forward. So it's pretty cool. You can program, mess around with that in the web. Just one example. Another one that, of course, maybe you've seen, maybe not, is Code.org. It has all kinds of different programming courses for you, but for instance, you can do programming with Angry Birds. Care about being signed in. So, and you can do, you know, things like this and hit run. So you can learn to program that way. And we're just looking at a couple other ones. Blockly, which is kind of behind Scratch, well, which is the library that's used to make Scratch, is a library you should be aware of. If you ever want to make a block-based language, do not make your own. Just build on top of Blockly. That's what Scratch does. That's what we did for our projects in the lab. So never make your own. Just build on top of this. It's a lot easier. A lot of people do it on top of theirs. Blockly is a very well-known library for building block-based languages. Check it out. There is, in addition to these visual languages that we've been talking about, there's also this kind of new movement to do low-code or no-code solutions. And so that's a thing that is becoming more and more common now. And so what I want you to be aware of is there are things like Bubble.io. This is just one example, and it's a way to build web apps without code. Kind of like the voice flow that we used. It's ways to build apps without using what we would traditionally call code. Although eventually they are all doing some kind of logic or configuration, but they allow you to do it without actually writing code as we would traditionally. And this is becoming a big space in the consumer market. All right, so I want you to try and guess. We've talked about almost all the different types of end user programming languages, but why don't you just guess what I would say are the types of end user languages? Just try and think of like types of languages that you've seen, and try and create some kind of like grouping of these languages. What can you all come up with? Just take a guess. It doesn't matter if they're right or wrong. These are anonymous anyway, so get out there. Let me know some guesses. Let's go. That's a very good guess. I like that a lot. Whoever did that. See if we can get another person to guess. I know it's Friday, but you can do it. Definitely do it, people. Let's go. Ooh. Okay, yeah, low code. I guess that is a type. Yeah. I would call that a type. Yeah. It's a good way to categorize these. Low code, block based. Yep. Definitely. I like it. What else you got? Node, yeah, or basically like let's call that graph, but yeah, like node, data flow, graph, whatever. I get what you're going for there. I like it. Okay, so there's like sequential, kind of like the block based, and then there's these events, and that is a very tricky, subtle issue you're getting into. Um, so that's a good idea and something we'll talk about later. All right, so I've tried to create a few types. Let's see what I came up with. Um, I'm pulling them down. So the basic types of end user programming. This is not a like official categorization. I just wanted to get across the different types that I've seen. They're basically block based, which is like Blockly. There are things that are like spreadsheets, like Excel. There are things that are like flowcharts, which are kind of like LabVIEW or like Node-RED or some of the video game stuff. Like Blueprints is a little bit like that. There are a very specific thing called behavior trees. You know how it follows the edges of the leaves of the tree, but that's not a very popular one, to be honest. And then there is what I would call configuration pages, where you're just like basically filling out web forms in order to program something like if this then that, and that's almost not even programming. And you guys mentioned low code, no code approach, and I'd say that's kind of like another type, similar to configuration, but it's more like WYSIWYG. I would say it's more like drag and drop, kind of put put things like put UI elements in its place kind of approach. All right, so you have a basic idea of what end user programming is now. Let's I think we're going to take a little quiz and see if y'all can come up with some of the answers. Like, let's just see how good of an understanding y'all have of end user programming. Like, as I mentioned, we're going to end class a little early today because I have to go to this provost meeting. But I wanted to see how good of an understanding y'all have in end user programming so far. We'll go over this again on Monday, but it's important for you to have a basic understanding of end user programming so that when this kind of question, like problem, you're faced with it at work, you don't choose the wrong one, or worse, way worse, you don't make up your own new way of programming, which is usually a disaster. All right, here we go. Let's see how y'all can do. What type of approach is Scratch? Is it a behavior tree? Is it block based? Is it configuration? Or is it a flowchart? Y'all look like you're doing very good. Everybody's already answered. Excellent. It is block based. Scratch is block based. Let's see who's in the lead. It looks like Meredith is going to be our leader right now, followed by Sean McRae, Amogus, LOL, bruh, Dud Nugget, XYZ, CT, and Demurred. All right, next up, question 204. What about LabVIEW? What would you consider LabVIEW to be? Remember, that's one that's used by probably millions of people. And it's similar to what you see in Lego Mindstorms. Um, this is a little tricky because they kind of look like blocks, but they operate more like something else. Let's see what you think. That's right. These are most like flowcharts. They basically operate in a flowchart kind of way. They're really good with data and collecting data, but they can be difficult for other types of tasks. All right, McRae takes the lead. Question 3 of 4. Where are behavior trees used? They are used in a particular domain, and I kind of mentioned this. What do you think? Where are they most likely to be used? All right, these are used in. Hold on a sec, I have to do this other thing. All right. That's right. Way to go. All right. I'm sorry. I have to go to my next meeting. It's with the provost. He's giving a talk right now. So I will see y'all on Monday. Thanks for your patience. See you on Monday. Bye bye.